let's take a look. Section 3.4. We talked about what was the last section on? Yeah, not the number. What was it on? It was slope. Okay. So what we're going to do is we're going to talk about two things today. Okay. We're going to talk about two things today. Well, a couple, more than two things, but let's do this. I'm going to make a nice little line here, and let's go like this, and let's go like this. I don't know, just make it go all the way down here like that. Alright? Now there's a lot of times. Now you may not see right now in either Algebra 1 or Geometry or even Algebra 2, you may not see exactly why this stuff is being used. Every once in a while they'll throw a word problem at you, but sometimes even the word problems they throw at you don't seem like they're very practical. It's things that we would really use. And to tell you the truth, in a lot of people's lives, this stuff may not ever be used, but there are a lot of people out there that use this kind of stuff. When you start getting into the sciences and you really start studying the sciences, you start studying biology and chemistry and physics and things like that, graphs are a huge, huge deal. All right, when you talk about those sciences, and they're very, very important. Are y'all paying attention? Look up here. Pay attention up here. All right, not whatever is going on there. Up here. Thank you. Graphs are really, really an important thing. We're starting at the most basic level that we could start at. Okay, as you go on and you learn more stuff, it gets more complicated, and it gets more useful. When I say complicated, it's not just that it gets harder, although it does, but it gets more useful. Things that people can actually use, and they use this stuff all the time. There's graphs everywhere. You just may not see it in your everyday walk and everyday life, but people use graphs all the time. So graphs are very, very important. So there's a lot of things about this that are important. And I'm going to redraw my graph just a little bit just to make it go through there. Okay, I did that on purpose. All right, so here we go. There's two things about this line that we could tell. First of all, we've already talked about this. We've already talked about the slope. Okay, secondly, there's another keep this red. There's another thing in here that's pretty important. I don't know. Do you remember this from Algebra 1? The slope was really important to this line, and there was another thing. This point right here. Say it, Isaiah. That's it, the y-intercept. Very good. All right, so let's write that down. So there are two things that are really important, and I'll number them. One is the slope, and two is the y-intercept. All right? So those are the two things we're really going to concentrate on right now. There's going to be some other things. There's also like an x-intercept. Not like an x-intercept. There is an x-intercept. I'm sounding like you kids. There's like everything, right? So anyway, there is an x-intercept. But we don't really use that in this equation that we're going to talk about. And you probably know what this equation is that I'm going to talk about. But we don't really use the x-intercept in this particular equation. There are other equations that we will use when we talk about the equation of this line that does have to do with the x-intercept. We're not going to deal with that this year. So don't even worry about the x-intercept just yet. Okay? It's the y-intercept that's pretty important that we're going to deal with. So we have a slope. What letter do we use for slope? M, right. And then, do you remember from Algebra 1 what letter we used to represent the y-intercept? It doesn't start with y, and it doesn't start with anything you'd think it would. It's really kind of like an oddball letter, you'd think. Anybody remember? No? B? Does B ring a bell? Does the equation ring a bell to you?
Y equals mx.
You got it. That's it. You remember this, don't you? Y equals mx plus b? Well, what is the m? We already said it. That's the slope. So the slope of the line would go right there where the m is. And now we just told you, what does the b represent? The y-intercept. I'm just going to shorthand it. Just put int. Is that all right? The y-intercept. What is the y-intercept? The y-intercept is this point right there. It's the point where the line crosses, right, the y-axis. Exactly right. Remember, this is the y-axis. Which one is this one? The x-axis. So this would be the y-intercept, this would be the x-intercept. In this equation that we're doing today, I don't care about the x-intercept. All right? Do you ever wonder why that's a b? Why in the world did they pick b? It doesn't start with it. Well, I'll show you why. I looked it up. I had to look it up on Google. I did it, I don't know, a couple years ago. I always wondered why they call it B. Kids would ask me, I'm like, I have no idea. Then they invented the internet, so I'm like, that's cool. I can look up to see why the B is there. So they usually use A to represent the x-intercept. So what do you think would be next? B would be used to do the y-intercept. Does that make sense? Yeah, it kind of does. So the A represents the x-intercept and the B represents the y-intercept. But in our equation that we're doing today, I don't really care about the x-intercept. Okay, I only care about the y-intercept. So I care about two things, the slope of the line and the y-intercept. You with me? So here's the formula. Right here, y equals mx plus b. M represents the slope and the y-intercept, or sorry, the b represents the y-intercept. The x and the y just stay x and y. So for instance, if I, let's get rid of this line. If I get rid of that, let's get rid of that. Let's get rid of this. All right, and what if I gave you a formula, just in a different color, we'll go like purple. If I gave you, I'm going to make it really easy. What if I had like 2/3 x plus 1? There it is. There's my equation. Oh, I should write this down. We call this thing, this y equals mx plus b, we call it the equation of a line. We're going to refer to that quite often, equation of a line. Now, there's a lot of different equations of a line. We're only going to talk about 2 of them, at least in here. As you go on, you do some more math. There are some other equations of lines that you're going to deal with, but for right now, let's just deal with this one, and then we're going to talk about another one in a couple minutes, okay? So this one right here has a certain name. Look, we have a slope, and we have an intercept, so guess what they call this? They call this equation of a line the slope-intercept line, right, or form. They call it the form. So the slope-intercept form. All right, that's what they call this particular one. Off the top of my head, I can probably think of 4, maybe 5 different equations of a line. All right, all have different forms. This is probably the most popular one, especially in high school. Okay, this is the one that you use probably more than any other form. It's this one right here, y equals mx plus b. All right, and you saw, as soon as you heard me start that, right, I had about 3 or 4 of you say, oh yeah, I remember it, and then you said the whole thing. Y equals mx plus b. You've heard that many, many times. But the name of it is called the slope-intercept form. Why do we call it that? Well, because it's got a slope and it has what? An intercept. All right, not just any intercept, the what? The y-intercept. Everybody got that? All right. Let's get rid of all this junk up here just so I have some room. I'll tell you what, let's just move this. And we'll scooch that up here. Look at that, isn't that cool? And we'll get rid of some of this stuff just so I have some room to write. Get rid of this. And we'll get rid of all that, might as well. We've seen it all. Ready? All right. What if I asked you to graph this thing right here? Here it is. So what is the 2/3? The 2/3 is the what? It's the slope. It's the rise over the run. Good. And what is the 1? The y-intercept. The first thing that I'm going to draw on here is the y-intercept. Okay? What does that mean? It means it's where the line crosses what? The y-axis. It's the y-intercept, so it's where the line crosses the y-axis. It crosses where? At +1. Where is 1?
Right there.
Right there. Okay, so I put a dot right there. You with me? All right, then we find the slope. From this point, from this y-intercept, we find the slope. Somebody already said it. It's what over what? Rise over run. So I'm going to rise how much? 2. 1, 2. I don't put a dot yet. Okay, and then I go over which direction, though? To the right, 3. 1, 2, 3. Put a dot right there. What do I do when I get those 2 dots? That's right, draw a line between those 2 dots. All right, like this. And then I'm just going to extend this one out. Don't necessarily stop from one point to the other. I've seen people do that. It's not really a line segment. It keeps on going, doesn't it? So technically, it keeps on going in both directions. So extend it out a little bit. Don't just start here and stop here. And I've seen people do that, and it's not good. All right? So make it look like that. And there you go. So if they gave you an equation, then you should be able to find, or you should be able to graph it. Right? Because you look at it and you say, okay, the y-intercept is 1, so I put a dot at the y-axis at 1. Then the slope is 2/3, so I rise 2 and I run 3. Look, I could have done this too. what's another way I could write 2/3? I could have written it -2 over -3, couldn't I? I mean, I don't know why you'd want to, but you could, because watch this. I could rise how much? -2, so I go down 2, 1, 2, and then run -3, which would take me where? To the left 3, 1, 2, 3. Right there, okay? No. I get the same person calls me. I just turn it off. All right. I'm a teacher. I'm not a student, so I don't have to put it in my locker. How about that? All right. So there we go. All right. Makes sense? So I could give you an equation. I could say y equals -5/3 minus, oh, let's put a 3 in there, minus, I don't know, 4. Let's say we did that. And let's change colors. All right, so what would I do? Oops, that's supposed to be an x right there. -5/3 x minus 4. So if I wanted to graph that, y-intercept is -4, so 1, 2, 3, 4, right? And then the slope is -5/3. Now watch, I can't go -5 on my graph, can I? That's right. It isn't -5/3 the same as this? We talked about that earlier, didn't we? All right, so if I don't have enough room to go down 5 and to the right 3, I could do what? I could go, no. I got to go rise over run. You got to rise that, and you have to run this. Yeah, go up 5. 1, 2, 3, 4, 5, and what? To the left 3. 1, 2. Let's see, count 1, 2, 3, right there. You see that? And then I could connect those, and then I'm good to go. All right, there's my line like this. Just extend this out just a little bit. There we go. All right, and that would be it. That would be that equation right there. Pretty easy, isn't it? So if I give you an equation, you should be able to graph it. No big deal. All right? Okay. What if I gave you just 2 points? I didn't give you a graph. All I gave you were 2 points, and you have to find the equation of that line. All right? Give me a second. Let me pause this, and we'll write it down. Okay, here's what they're going to do. They're going to give you 2 points, and they're going to ask you to write the equation of the line. So what's your answer going to look like then? I mean, don't give me exactly what it is, but what's the general look of it? Y equals, right, mx plus b. So really, we're looking for how many things? 2 things, right? We're looking for the slope, and we're looking for the y-intercept. Let's find the slope first. We just went through a whole lesson, didn't we, on how to find the slope, correct? So let's find the slope right off the bat. Isaiah, what do we do? Okay, give me some numbers. You sure? It's y. It's y. Subtract the y's first. So what is it? 3 minus -1, right, over 0 minus -2. Okay, don't forget that. It's rise over run. It's y over x. So you subtract the y's first, right, not the x's. It's a common mistake that a lot of people make. So make sure that you don't do that. So minus a negative, that's 4. And that's what? +2, correct? Because that's minus a negative. And what does that reduce to? 2. So the slope is 2, isn't it? I'll just circle it. It's not my answer, is it? It's just the slope. They want you to find the equation of the line. I'm not going to write it down, but they say find the equation of the line that goes through these 2 points. So I found the slope, which is 2. Now what do I want to find? The y-intercept. Now let me tell you something right here. Do you see this x and y? It's just been sitting there as x and y. We're not really sure what it meant. What it means is this. Remember, if you have an xy, that's a point, isn't it? Well, that represents any point on my line. So do I know any points on this line? I know this one and I know this one. I know 2 points on my line, don't I? So I can pick either this one or this one to put in for x and y. It doesn't make any difference. I got to do this less than a minute, so let's do it. So I've got y equals m. What's my m? 2. Okay, x, right, plus b. This x and y, I can actually take either this point or this point and throw it in for that x and y. Which one do you want to pick?
0.
Okay, let's pick this one right here. It doesn't matter, and I'll show you. What do we put in for y then? 3. I'm running out of time. 2 times 0 plus b. What's 2 times 0? What's b equal to?
3.
It's equal to 3. So look, I've got my slope right here. I've got my y-intercept. Now we got to put it all together. Now watch what I do here. It's y equals 2x plus 3. That's the equation of a line that goes through those 2 points.